Okay, so this is Alkenes Nomenclature. Keep in mind that alkenes are compounds containing one carbon double bond. First, you have to pick the longest parent chain containing a carbon double bond. It cannot be this one, because this obviously does not contain a carbon double bond. However, the one already circled in red, it is this one because it contains that carbon double bond. So when you want to begin numbering, you want to begin at the end closest to the first carbon double bond, which is this end right here in pink. So we go 1, 2, 3, 4, right? So this is not like alkanes where we gave priority to the substituent, right? Even if we were giving priority to the substituent and this were a alkane, you would still number it this way. But we're not looking at substituents when it comes to alkenes, right? The E is the suffix, and we are looking for carbon double bonds. So third, naming the parent chain. You are going to replace the ane ending of the alkane name with an ene ending. So ethane becomes ethene. So next, you indicate the placement of the carbon double bond with a number before the prefix of the parent chain name. So it goes number and then alkene. The number of the ene is where the carbon double bond begins. So right here, our carbon double bond begins at 1, right? Because our initial rule is begin numbering at the end that is closest to the first carbon double bond, and that makes our parent chain begin right at 1. So when we name, we say 1-butene, right? Because this is 1, 2, 3, 4, a 4-carbon chain, which makes it butene. So our carbon double bond begins at 1, which is why we put that 1 right there. That 1 is indicating the beginning of the carbon double bond, right? And then the carbon double bond ends at 2. Fourth, we have to ID and name the substituents. List the substituents before the parent chain, number, and name. So this is the same as alkanes. Alkanes, you name them just like this. It's 2-methyl-1-butane, right? The parent chain is 1-butene because the 1 stands for where the carbon double bond begins, and butene stands for the 4 carbons, and then the substituents are 2-methyl. So 2-methyl, just like how it is in alkanes. This is neither cis nor trans, so we don't need to include the cis or trans. Okay, so now we take a look at cis and trans, and then E and C, we'll get into that into the next one. So it is necessary before any substituent names, and because there's fixed geometry and no rotation around carbon double bonds in alkenes, cis and trans become more common, right? However, not every single one has to have it. Like up here in number 4, this one is an alkene, right? The ene stands for the carbon double bond. However, it didn't have a cis or trans configuration. So and by the way, again, remember that there's no rotation around here because otherwise it would be orthogonal, which is 90 degrees, and that would cause the bonds to break. So the hydrogens up here, right, we draw these in because this carbon will have carbon 1, 2, 3, 4. That's a total 4 bonds, right? Keep in mind that this double bond is 2 bonds, right? Duh. So we draw in the hydrogens. They're pointing in the same direction. These have 2 different substituents, which are also in the same direction, which makes this a cis, right? Cis 2-pentene. We start numbering from this side over, right? Because that gives the double bond the starting point of 2. If we were to have started from this side, it would be 1, 2, 3, and 3 is not smaller than 2. So this is saying that the double bond starts at 2, and it is a pentene because it has 5 carbons. The ene stands for the double bond, right? Over here on this side, we have trans. So we, again, double bond, carbon, 1, 2, 3, 4. We draw it in, right? So the hydrogens are on opposite sides of one another. The 2 different substituents are also on opposite sides of one another, which makes this a trans configuration. Next, we have an example where we can't really use cis or trans, right? So yeah, there's 2 different substituents. However, only one of the carbons has a hydrogen. This one right here has another CH3. It has another carbon attached to it. So this is 1 bromo, 2 chloro, 1 propene, right? And again, the 1, we started at the carbon double bond, and we're pretty much saying that the parent chain name is always where the double bond starts, and then the name of the parent chain, which would be propene. And obviously 1 is attached to bromo, 2 is attached to chloro. So 2 different substituents on each carbon. 2 carbons of double bonds do not each have a hydrogen attached, so we cannot use sister trans configurations. That's when we look over here for E and Z, right? So E has 2 higher priority groups are on opposite sides of the carbon double bond, and for Z, 2 higher priority groups are on the same side of the carbon double bond. So nomenclature, right? Based on the group priority of the substituents attached to each carbon in the carbon double bond. So priorities 1 or 2 are attached to the 2 carbons in the carbon double bond. Assign priorities using the old one. And by old one, I just mean like in stereochemistry, how we did the initial priority assignments. Okay, so right here we can go over this briefly. This carbon right here, bromine, higher priority to hydrogen. So bromine is going to have the number 1, right? This one right here, chlorine higher priority than CH3. So this one has the higher priorities, and that is above, right? They are on the same side, kind of, which gives it a stereochemistry of Z. The 2 number 1s are on the same side. It is a Z, 1 bromo, 2 chloro, 1 propene. Let me copy this over so that I can go over it with you. So we have this, right? We can start by naming the entire thing. What is going to give us if we start from what side will we have the lowest number on the carbon double bond? That's on the right side, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tells us that this is nonene, and 4 tells us that that's where the double bond starts. So we have 4 nonene, right? We have the bromine right here, bromine on the 4, and then we have an ethyl, because it's 2. So we say that this is a 4 bromo, 5 ethyl. Let's move this over. Ooh, that's bad. Oh Lord. 4 bromo, 5 ethyl. 4 nonene. That's the name of it, right? Now we need to see, and again, let's take a look at this, right? We don't have a hydrogen coming off of both, right? We have this totally different substituent, this totally different, this different, and this different. And what they have, all of their bonds, 1, 2, 3, 4, 1, 2, 3, 4. There's no hydrogens, right? So what do? We can split this in half, okay, and then we assign priority. 5, 4. Let's name 4 pink, okay? Bromine has the higher priority compared to the carbon, right? Compared to this carbon right here. This has the second. Next up, we can do blue. 5. This whole thing is going to have the highest priority, so we name this number 1, and this thing right here, the ethyl, will be number 2. What do you notice? The highest priorities are on the opposite side. So because they're on the opposite sides, we're going to name this E, right? Because up here, we said that the 2 higher priority groups are on opposite sides of one another, and that's right. We can put parentheses.